This word problem says find the length of a pendulum that vibrates 5 times in 1 second. So go ahead and pause, try to solve this word problem, and when you're ready, check your answer. Let's write down what we're given. So 5 times in 1 second. So you have 1 sec, so that's going to be a time. And you have 5 here, so 5 is just a number. So we can actually call this a number of cycles. And we're trying to find the length of the pendulum. So let's see how this works. So you have your support here. You have a pendulum. It has a length L. And this pendulum is going to cycle back and forth 5 times in 1 second. So the equation that we're going to use is going to be the equation for the pendulum. The period is going to equal 2 pi multiplied by the square root of the length of the pendulum divided by g. But we're also going to use the equation frequency is going to be number of cycles divided by time. So here, for this one, let's get the frequency first. So the frequency is going to be, so it vibrates 5 times in 1 second. So it's going to be 5 times in 1 second, so the frequency is going to be 5 hertz. And the period is defined as 1 over the frequency. So 1 over the frequency. So this is going to be 1 over 5. So the period is going to be 0.2 seconds. Next, we're going to use that to get to find the length of the pendulum. So we use the equation period is going to equal 2 pi multiplied by the square root of the length of the pendulum divided by g. So here we'll have to do some algebra. So let's divide both sides by 2 pi. And you get that period over 2 pi equals square root of L over G. And next thing, let's raise both sides by 2. So that the power of 2 cancels the square root. And then you get that period over 2 pi all squared equals length over G. And last thing, let's multiply both sides by G so that they cancel here. So then the length of the pendulum is going to equal G multiplied by the period over 2 pi squared. So that's going to equal 9.81 multiplied by the period, which is 0.2, and divided by 2 pi, and then all that squared. So that should give you 9.9 times 10 to the minus 3 meters, or 9.9 millimeters. Next, try this one. An ultrasound transducer sends a sound wave at 20,000 hertz. If the sound wave travels through muscle at 1,580 meters per second, what is the wavelength of this ultrasound wave? So go ahead and pause, try to solve this yourself, and then check your answer. All right, let's write down what we're given. So we have 20,000 Hz. So that's Hg, that's hertz, so we're given a frequency. And next we have 1580 m over s, so that's going to be a velocity. And we're trying to find the wavelength. So the equation for this one's pretty simple. The velocity is going to equal the frequency multiplied by the wavelength. So let's divide both sides by the frequency so that it cancels. And so the wavelength is going to equal the velocity over the frequency. So that's going to equal 1580 divided by 20,000. And the wavelength is going to equal 7.9 times 10 to the minus 2 meters, or 7.9 centimeters. All right, next one. It says, what is the speed of sound in air when air is at A, 100 degrees Celsius, and B, when air is at 0 degrees Celsius? So pause, try to solve it yourself, and when you're ready, check your answer. Let's write down what we're given. So for A, we're given 100 degrees C, so that's going to be the temperature in Celsius. And for B, we're given 0 degrees C, so that's also going to be a temperature in Celsius. And for both cases, we're trying to find the speed of sound. So the equation that we're going to use for this one is going to be the speed of sound is going to equal 331 plus 0.6 multiplied by the temperature in Celsius. So this is just a plug in here. So for A, the speed of sound is going to be 331 plus 0.6 multiplied by 100. So the speed of sound at 100 degrees Celsius is going to be 391 meters per second. And then for B, the speed of sound is going to be 331 plus 0.6 times 0, which that just cancels. And you get that the speed of sound at 0 degrees Celsius is 331 meters per second. This word problem says an ultrasound emits sound waves at 1,000 hertz and is used to image a human tissue. The speed of sound through tissue is 1,600 meters per second. If the transducer approaches the tissue at 0.5 meters per second, what is the frequency received by the tissue? So go ahead and pause, try to solve this, and when you're ready, check your answer. So let's write what we're given. So we see here that there's 1,000 Hz. So let's also include the decimals. But HC, that's our frequency. And next we have a 1600 ms. So that's a velocity. And we also have a 0.5 ms. So that's another velocity. And we're trying to find a frequency. All right, so here let's do a picture to see what's happening. So what's happening is this. You have a transducer, and it's sending out a sound wave. And the sound wave, that's going to be the frequency of the source. So that's going to be at 1,000 hertz. So this is this is the frequency of the source. And that sound wave is moving at a velocity. It's moving at the velocity of sound, which is or the velocity of a wave, or the velocity of a sound wave. So I'm going to just call that V wave. And that one is going to be this one over here. So that's the 1,600 meters per second. And next, the 0.5, what's happening is that there's, like this is, for example, your arm here. And it's approaching at a velocity. So here, the transducer is moving towards the arm with a velocity of 0.5. So this is going to be the velocity of approach. I'll just say VAPP for velocity of approach. And that is equal to 0.5 meters per second. And from that, so if this is used, this is your ear standing here, what frequency are you going to observe? So we're trying to find what is the received frequency. So the equation that we're going to use is the received frequency is going to be the source frequency, and then multiplied by this factor, which is going to be the velocity of the wave, divided by the velocity of the wave plus or minus the velocity of the source. And because this one is approaching, we're going to use a minus sign. So approaching is going to mean we're going to use a minus sign. And so here we can just plug in. So the received frequency is going to be 1000, and then multiplied by the wave velocity, which is 1600, and then divided by the wave velocity, 1600, and then minus the approaching velocity, which is 0.5. And that is going to give you a received frequency of 1000.313 hertz. So a slight increase in the frequency as the transducer approaches.